at the law of flotation, which is derived from that principle. The law of flotation states that a floating body displaces its own weight of the fluid in which it floats. This means that the weight of the floating object will be equal to the weight of the fluid it displaced. The same goes for the mass. According to the law, objects with the same weight as water may float or sink in water. For example, let's take a 1-ton block of solid iron. Iron is nearly 8 times as dense as water, which means that when submerged, it only displaces 1/8 of a ton of water. Therefore, it cannot float because its density is much higher than water. Let's look at 2 examples of this law in daily life. Ever wondered why ships and submarines can float when they are so large? As we know from the law of flotation, an object must displace a weight of the fluid equal to its own weight in order to float. So a 10,000-ton ship must be built wide enough to displace 10,000 tons of water to stop it from sinking. This we call the principle of flotation. So even though we could make the ship have much smaller volume with the same mass of 10,000 tons, its density would increase, which would make it denser than water, causing it to sink. The same is true for vessels in the air, as air is a fluid. In order for this 100-ton dirigible to float, it must displace at least 100 tons of air. If it displaces more, it rises. If it displaces less, it falls. And if the dirigible displaces exactly its own weight, it hovers at a constant altitude. It's an amazing discovery that has led to many inventions, including enormous cruise ships that can fit over 6,000 people on board. So how do we measure the relative density of liquids? Meaning the ratio of the density to an equal volume of water. We use what is called a hydrometer. This instrument is usually made of glass and consists of a cylindrical stem and a bulb weighted with mercury or lead to make it float upright. To do the test, we pour the liquid into a graduated cylinder. Then we lower the hydrometer into the liquid until it floats freely. We then take note of the point at which the surface of the liquid touches the stem of the hydrometer. Hydrometers usually contain a scale inside the stem so that an accurate reading can be taken. And that's how you measure the relative density of a liquid. Let's review what we've learned. We know that the law of flotation is derived from the Archimedes principle. The law of flotation states that a floating body displaces its own weight of the fluid in which it floats. This means that a 10,000-ton ship has to displace 10,000 tons of water in order to float. We call this the principle of flotation. This means that anything denser than the fluid would not float. That's why a balloon filled with helium floats, but a balloon that you would blow up yourself does not float. The helium gas is less dense than the atmosphere's air. We also know that in order to measure relative density in a laboratory, we can use a hydrometer, which is a measurement instrument. The law of flotation is fundamental in engineering and has led to some truly amazing discoveries. Can you think of where else the law of flotation could be applied?